Hi, I'm Jeff Cogswell. Today at Go Parallel, we're going to look at how to use Advisor in testing out an algorithm for solving an n-queens problem and figuring out where we can put parallelization in it and test for possible problems such as data races. Now, the n-queens problem is, very briefly, a board, a chessboard, where you can place queens on it, and queens can move in any direction on a chess game as far as they want. They can move up and down or diagonally as far as they want. And what you want to do is position your queens on this board so that no two pieces are diagonal or in line with another. So for example, because I've got a queen right here, I can't have a queen next to it because those two are in line. Similarly, I can't have a queen below it because those two are in line. Or down here, because this one is in line with this one and it's in line with this one. I also can't have it diagonal. The idea being a queen can go in any direction and kill an opponent's piece, and you don't want the queens to be able to kill each other. So this is a solution right now to a 4x4 board. The examples that come with Intel Advisor XE include an n-queen solution, and it takes a good while to run, and it starts out as a serial program. And the examples include ways to use Advisor to add parallelization to it. Now, what I want to do is look at that code and show you a slightly different approach to tackling it that's different from the way the other tutorials and whatnot do. Now, in the previous video, I recommended going through this code and fully understanding how it works. If you haven't watched that video and you're not familiar with the n-queens problem, I strongly encourage you to take a look. Down here is the main entry point for the solution, and it does a loop 0 to size, where size is the size of each dimension of your board. So for example, this is a board of size 4 because there's 4 across and 4 down. This example creates one instance of the board and then starts solving it. Now, if you're familiar with parallel programming, you can probably already see that that's going to be a problem. And that's one thing I want to do here is most people who want to learn how to use Parallel Studio in this regard are probably somewhat familiar with parallel programming. And you can probably see that having a board and then calling a solution on it is probably not going to work. And in fact, Advisor does tell you that it is a problem. And also, we're doing a loop here. Typically, you want to do two different kinds of parallelization, vectorization, and multi-core. In this case, we might want to try multi-core. If we look up at this code that is calling setQueen, you can see there's another loop down inside it, which again calls itself recursively. Now, when you run Advisor, you find that there's what they call a hotspot right down here, which they suggest is a good place for parallelization, and it turns out it is. What I'd like to do is just see what happens. Suppose that we're not familiar with Advisor, and just play with it, just so we can get familiar with it, and see what happens if, for example, we put some code in, some parallel code in that's probably not the best choice. So let's open up Advisor. What we do is we right-click on the project, and then come down to, it's down a little bit here, Intel Advisor. We open Advisor Workflow. And we switch our build to release. Now you have to use release, however, you do need to have debugging symbols turned on, which I'll switch back here for a second. If you go into your properties for your project, go to C, C++, General, and debug information format. Make sure it's set to program database /ZI. Then you'll be good there. And now you can go ahead and start the Advisor. The way this works is open up this window and click Collect Survey Data. And what it's going to do is it's going to run your program, and it's going to look for what they call hotspots, where it seems to be spinning inside of a loop that could probably be parallel. So now it's running. And now it's collecting the data. And here you can see where our hotspots are down inside this loop. If you click on this, you can see that some really high numbers here where it's spending most of its time. And it gets smaller because those are just smaller pieces of it. So let's go into here to the solve one. Now what they recommend doing, if you work through the examples online, are putting some annotations around this solve spot here. What I want to do is, instead, let's do it up here. Here's how you do it. We go back to our code. You can double click here. That takes you to your code. I want to do an analysis on this spot right here. So I'm going to right click. I'm going to do Intel Advisor XE. I'm going to click Annotate Site. Now I'm going to move this down just a little bit because I want this whole for loop inside there. And then inside there, I'm going to do Advisor Annotate Iteration Task. So now I want to see what happens if this can be parallelized. So I'm going to save it. Now to test suitability, we keep it to the release mode and make sure we're built. And we do collect suitability data. Now it's running. And now we have our suitability report. I'm going to close this up and scroll down. Now what I want to point out here is, notice that we don't gain much. Each of these bars is an increase in the number of cores. Now we're really not gaining much at all. In theory, we are getting a gain initially, but then as the cores go up, it actually goes down. However, there's a bigger issue, which we'll see in a second here. This thing doesn't, so far, it's not bad in parallelization, but let's find out if there's a bigger problem. As we know, that algorithm is recursive, and it's calling into the same data over and over, which is probably not going to work out in terms of parallel. So let's see what Advisor tells us. The next step is to switch to debug mode. Go ahead and build it. And then do check correctness. Check correctness requires debug mode, and then click collect. Now a point here. Advisor doesn't actually add parallelism. Advisor only suggests where you can put parallelism, and then it uses some tools to determine if it's probably going to work for you. However, it doesn't actually modify your code in terms of adding parallelism. Okay, now here we go. Notice right here it says data communication and memory reuse. What those both mean is that it found an error. The little x means there's an error, and in fact it found both of those basically amount to a data race. Now if we look at our code here, when we call setQueen, we're passing in our data structure into the setQueen function, and it's modifying it. And we're doing that inside this loop here. Each time it's modifying it. So you can probably see right there that it would make sense that that's probably a data race. But the reason I wanted to do this was to show you that Advisor can actually find that kind of problem for you. The real solution, which I'm not going to do it right now, you can work through it yourself. The real solution is to follow the steps through Advisor, and it'll recommend making just this outer loop up here in the solve parallel. And you go through the steps and you test it out for suitability, and you'll see it is suitable, and then you test for correctness, and you'll find there is another problem. There's a problem right here. With each loop, we increment the number of solutions. Well, we know as readers of Go Parallel, we know that if you have something you're incrementing each time inside of a loop that's running in parallel, you have to use a reducer, and that's what this will spot. It will show you that there's a problem there and suggest fixing that, which is to put a reduction in. So that's a little bit different approach to this example. It's a perfectly legitimate way to use Advisor. I didn't use Advisor in a different way. I went through the steps, but I went aside from the example that they provide and tested out a spot in Parallel that they had not mentioned. And sure enough, Advisor was able to tell us that that really is not a good spot.